say that P equals 9 when Q equals 10, R is equal to 3, and S is 5. What should be the value of P when Q is 12, R is 2, and S is 9 if P varies jointly as Q and R but inversely as S? We cannot jump into any decision as to what type of formula we'll be using here because you need to understand how this problem is being stated. In the last part of this problem, it is stated there that if P varies jointly, that would mean it's an example of a joint variation. However, it's not yet done because you only have jointly as Q and R, but inversely as S. So we have joint and inverse variation at the same time. If you have examples like this automatically falls to a combined variation. A combined variation could be a combination of joint, inverse, direct, or direct square. And for any combined variation, there's no specific formula. The formula will depend on how the problem was stated. In this case, we need to identify first what are the variables. We can see again on the last part of our problem, if P varies jointly as Q and R but inversely as S, we know that P is your dependent. And then we have three different variables for our independent portion, the Q, R, and S. Right after that, we can now construct its formula. So we know that it's P that will vary upon the three different variables. So we could write it here that P is equal to, and since it's a variation, we will be using K. K is a constant of variation or constant of proportionality. It's very important here because this value of K is same all throughout the problem. Upon using the first set of values, we could get a value of K, and we'll be using that same to get any other unknown that follows. But let's continue here. P varies jointly as Q and R. Joint variation is simply an extended form of direct variation. In short, they're under multiplication. So K, Q, and then you have your R. But inversely, you will have your rational expression here as S. So this is an equation, or let me put it here better. Right, that. So this is the correct formula for this problem. P is equal to KQR all over S, jointly as Q and R, but inversely as S. Now that we have that, the next is for us to determine the variables. Since P is our dependent, let's put it last. And you have here Q, R, and S. In the first statement, P is 9. When Q is 10, R is 3, and S is 5. So we will be using this and plotting it here, our formula, for us to get K. And that K will be used to solve the unknown. The value of P when Q is 12, R is 2, and S is 9. So we have these values now. Let's start with the solution for K. So let's plot it here. 9 is equal to, using these values here, K times Q, which is 10, times R, which is 3, times 5, which is S. That's 5. So we can divide 10 by 5 to get 2. So you will get here 9 is equal to K. 2 times 3, you'll have 6. Divide both sides by 6. You will get a result of 9/6, or in lowest terms, 3 halves. We will be using this to solve for P on the next statement and using the same equation. You will have here P, because that's what you would be solving. K is now 3 halves. Don't worry about multiple fraction forms here. We might be able to solve this easily with consideration to whatever with the next values. You will have Q, which is 12, and you have your r, which is 2, using this next set of values all over 9. So we could actually remove this here and like that. So we'll have 3 times 12. So P is 36 all over 9, which will give us a result of P equal to 4. In short, when K is 12, R is 2, and S is 9, P is 4. Again, in sentence form, when when Q is equal to 12, R is equal to 2, and S is equal to 9, the value of P is equal to 4. This completes our process. This is how we solve a combined variation like this. The more you practice, the better the chance to understand math. This is a direct variation statement for math success. Let this K, the constant of variation, be this channel. In other words, the more you practice with your subscription, the better the chance to understand math. Subscribe now.